Okay, let's start lab 4. You seem so distant. So first some introductions. So one of the main reasons we want to study the relationship between the response variable and the explanatory variable is we want to make reliable predictions. So when we got an regression formula and we want to use the explanatory to predict the response, and if we get a new explanatory variable, we want the prediction to be still valid, still reliable. That's we mean reliability. Okay, so we must determine if there do exist a relationship between the response and the explanatory variables, and we want to study what's the nature and the strength of the relationship. Okay, the setup of the lab. So we're gonna use the guess distance and the true distance between two objects to be our x and y variables. So the guess distance as x and the true distance as y. Okay, so if there is a relationship between the guess and the choose, then we can use the guess distance to predict the true distance. Okay. So data collection, so for online labs. So this have been modified. So for the online version. So we stand in the middle of some area. So it can be in the middle of a room or you can go outside. Okay. So mark where you are standing. So it will be your reference point, and it will be marked, and you will measure the distance from this point to the object you choose. So you identify 11 objects you can access in a straight line, and then you fill in the second column of table 4.1. So second column, so object descriptions. So you find 11 objects. So object you find can be a cup or a tree or some other thing you can choose on your own. Okay, just make sure you are able to measure the distance in a straight line. Okay. Okay, after you choose 11 objects, then you need to guess the distance. So you don't need to worry about how accurate you guess are. So you just need to guess the distance and put them as the x variables. Okay. So after all guesses are made, so the next thing for you to do is find the true distance between the reference point and the objects. So you can use a physical measuring tape, or you can download a tape measure software. So there's a free app called Tape Measure. Okay, and you take 3 different measurements for each object, and you plot these measurements in the 5th column. So you have 3 observations, and you put them together in the 5th column. Your team's measure distance. Okay. Then you find the median of the 3 measurements and put it in the 6th column. So true distance. So this column. Okay. This column is for the median. Okay. Then at this point, you have already finished table 4.1. You can leave the team to measure distance blank. So you can leave this column blank. Okay. Then you need to answer the discussion question 1 on page 30. So also the question have been modified due to online. So here's the modified questions. Okay. So after you finish discussion 1, then the data collection part is finished. We will move to the data analyze part. Okay, for data analyze, you first log into StatCrunch. So you click open StatCrunch, and you open a new blank sheet, and then you rename the first column as guesses and the second column as the true, and you input the 10 value you get. So the guess distance, you have 10 guesses and 10 true values. So you leave the 11th object blank. So we're going to use the 11th object as a testing point. So we're going to use the first 10 to build our model, and then use the 11th object to test our model. So then what we're going to do is we're going to create a scatter plot. So it's graph scatter plot. So you just click graph scatter plot here. and follow these instructions, you can get a scatter plot. With the scatter plot, you will be able to finish this question 2 and 3. Okay, so you can answer whether you are overestimate or underestimate. Okay. Then you can start to build your regression analysis equation. So you're gonna build one for simple linear regression, and one for quadratic forms. So make sure you have a copy of the regression output for the graphs and also the output for both of the models. Okay, so here is the instructions you can follow. So in polynomial, be sure to have order 2. Okay, so with the model established and we get the root MSE and the estimate of the error standard deviation, that's how we measure the performance of our model. And then we can finish the table 4.2. Okay, here. So you enter the error standard deviation here. So quadratic root MSE here, and the estimate of error standard deviation. They are eventually the same thing, so we call it S. And then we enter the 95% error, prediction error 2S. So it is a range from negative 2S to plus 2S. So you use negative 2 times the root MSE or the error standard deviation you get. So the numerical values, you time negative 2 for a lower bound and the plus 2 for an upper bound. That means the 95% prediction error means 95% of the time your error will be within this range. So when you make a prediction, and your error will be within that range. So when you have a new prediction, okay, that's which is your 11th object. Okay, so with this you will be able to fill in table 4.2. Also for this question, you can just based on your observation of the graph to answer it. These two. Okay. Then table 4.3 on page 30. So you need to choose a model. So based on your observation for error standard deviation or the 95% prediction error, or you just look at the graph, just can choose one model based on your observation, and you can choose either one and just validate your reasoning and choose it as your model, and then we're going to validate it using our 11th object. So here you need to write the formulas for the model, which is a plus bx or a plus bx plus cx squared. So you need to enter the real numerical values for it. Okay, so you enter a plus bx for the linear and a plus bx plus cx squared for the quadratic model. Okay, so then what you need to do is use the values here to calculate the prediction for the 11th object. So you first have a guess for the 11th object, which is your x. So you plug in that x, and to get your values by plugging into this equation or this equation here. So on the third row, you enter your formula. In the fourth row, you enter your guess distance, x, which is this value. The guesses for the 11th object, this value. Okay. And then you calculate the prediction y hat based on your formula by plugging this x. So you can write your answer here. So for example, you have a equals 1, b equals 2, then it's 1 plus 2x. You plug in it and calculate your results. Okay, you solve for y. And the true distance y for the 11th object is you measured it. You already measured it. That is your true distance. And the y hat based on your equation is the predicted distance. Then we can calculate a residual based on the y and y hat. So you on the fifth row you enter the true distance for the 11th object, which is measured by yourself. And then you enter the residual, which is the true y minus y hat. So you use this one to minus the results you get from the first row, okay, which is y hat. And then you can check if your residual, this value, is within the negative 2s to 2s range, which is this range if you choose a linear model, and this range if you choose quadratic model. So you can answer yes or no. Does that fall within the range? So in theory, 95% of the time it will fall within the range. Okay, with the three tables and also the regression reports and graphs, you'll be able to answer this question number 5 and 6. And also, be sure to turn in all the work, so which is the scatter plot and also the 2 regression output with graphs, and the table 4.1, 4.2, and 4.3, and also with the discussion question 1 to 6. Okay, thank you.